Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Lane by Sri Chaitanya. This is Suresh, Faculty of Chemistry. How are you all doing? Good afternoon. Nice to see that group of students are there in the chat box. Nice. And let's start with the second law of thermodynamics in today's class of interest. And the second law of thermodynamics is before this we completed first law of thermodynamics, where we discussed all energy and work conservation and all. And the second law of thermodynamics we are going to start before we just talk about the limitations of first law of thermodynamics. So as a procedure, we just talk about what Infinity Learn is doing for the students preparing for the NEET examination. Dear children, here Infinity Learn is offering various courses where the students got benefit of that. You can see double your score, proven results with our NEET droppers program. In this program you can see NEET 2023 versus NEET 2024 program. There is a huge increment in the hello Abhishek, and huge increment in their marks. So let's see, Ashrita got 310 marks in 2023 and she got 661 marks. There is an increment in 351. That is possible. Hello Abhishek, how are you? Good afternoon. Yes, thank you very much. We'll start the session. Wait a minute. And you can see Akhil Verma, who got 313 marks in 2023 and he got 658 marks in 2024. There is an increment in 345 marks. And Himadyuti, she got 310 marks in 2023, she got 652. You see how much increment she got, 342 marks in Badge. And also you can see Satyanarayan, she got 330 marks. He got a 330 marks in 2023 and 650 marks in 2024. 320 marks badh. So you see, this increment is possible by only the academic program that is driven by Infinity Lane by Sri Chaitanya, where you can see, and many more students are there like this, and you are following this Infinity Lane program and you will be the next for this 2025 NEET results. Are you ready for that? And let's see here, crack your NEET, and for this you follow our lessons, our programs on YouTube platform on regular basis without fail. And please like, share and subscribe to Infinity Learn channel, right? And also SEO test prep with Infinity Learn, and we have Infinity Learn Meta app, and you can download from the description box. And you can also see we are on the social network and Instagram, and we are on LinkedIn, and we are on YouTube, and you can have Infinity Learn Sri Chaitanya app as well. And Abhishek, so no late, we'll start second law of thermodynamics. Give one more minute please. And you have joined our Telegram channel. In the Telegram channel, we are going to offer you all the sessions, their schedules and their session notes in the PDF form, daily quizzes and doubt removals, and everything is available. And also first India's artificial intelligence guided programs are there, academics mein, and it is there. In that you will be having a test prepare analysis. You can create your own test and self-study modules and doubt removals and goal settings. Everything is done by AI powered tools, right? And also one important thing I just want to keep it in front of you, and score. This is India's largest scholarship exam. This is conducted by Infinity Learn by Sri Chaitanya. It is completely online, and you are going to get 100% scholarship depending upon your performance benchmarking, and it has been launched. It is meant for grade 12, grade 3 to grade 12, anybody can, and which can say scholarship worth of 1 crore and study setup, and you are going to get a laptop, and you are going to get educational conventional allowances, and you need not be a product of Infinity Learn, or you need not be connected to Sri Chaitanya or Infinity Learn. You can be from any organization, from any school, but you are eligible for writing score examination. believe it, and up to 100% scholarship. And you can just check the score examination and related thing, it is given in the comment box and it is pinned there, and you can just click it up and you can get it what the details are. And you fill the registration form, it is available and you can do. And let us start the second law of thermodynamics. Before going for the second law of thermodynamics, we will just talk about the spontaneous process, non-spontaneous process, entropy, and second law of thermodynamics. This is the course. This is the topic of the day. Okay, Abhishek Acharya. And let's talk about what are the limitations of the first law. So, first law, what first law says? Somebody, Abhishek Acharya, what is first law? Abhishek, come on. First law says, ये सिस्टम का जितना एनर्जी दे रहे हैं उतना काम कर रहे हैं, है ना? A system is given some amount of energy, it is doing a same quantity of work. A system cannot work, it is impossible to design a machine, a perpetuate machine which can work continuously without continuous supply of energy. And a thermodynamics can be defined, first law of thermodynamics can be defined in various ways. Yes, energy neither be created nor be destroyed. Yeah, U is equal to Q plus or minus W. If work is done on the system, W is positive. Work is done by the system, W is going to be negative. It converts one form to another form, that's good, very nice. If some quantity of energy is disappeared, same quantity of another form of energy should appear. Or otherwise, Kushi Gupta, some quantity of some energy is disappeared. The equivalent quantity of the work should be done. So, energy and work are interconvertible. Kushi Gupta and Abhishek Acharya, and somebody is there with no name. I just want to know the name of the students. Okay. Okay, let us talk about what we can do. Float. First law helps in determination of energy changes in terms of heat and work. Kushi Gupta, right? And but it does not tell anything about, there are two important parameters. Somebody can prompt me before I disclose that. Before I disclose that, somebody please prompt me. Total energy of the universe is constant. That is true. First you please tell your name so that it is feel comfortable for me to interact with you. It's nice interaction with you. Okay, so total energy of the universe is constant. So let Teja, good, Teja, and it's very nice, Tejas. Okay, one name Tejas with almost 5 years ago one student was there. Okay, anyways, before we learn the second law, we need to learn the need to learn the second law. That is important parameter you need to know. So there is something, a lacuna is there, there is some flaw is there, there is something which is not able to explain from the first law of thermodynamics is there. So from there, first law is true, no doubt about that. First law is absolutely true. But the first law cannot extend so many questions. So for that we need to learn the second law. So limitations, it cannot predict the feasibility of the reaction, perfect, and the direction of the reaction, absolutely correct. Feasibility or spontaneity and the direction, and the process direction is not explained. That I want to say, it cannot explain feasibility of the process and it cannot explain the extent of process. That's absolutely correct, Teja. Nice, nice. And let us talk about the second law of thermodynamics. Directly second law of thermodynamics definition is given. Okay, anyways, I'll come back to the second law of thermodynamics again, but formality's sake, let us complete the statement of first law of Tejas. Yeah. Second law of thermodynamics says, and it is impossible to build, you just ignore this, it is impossible to build a cyclic machine operating between two temperatures which can convert 100% heat given to the high temperature into work without liberating some amount of the heat at low temperature. I mean to say, it is impossible to construct a machine with 100% efficiency. You listen correct. What first law says? What first law says? Let us say this is a machine. So what is your favorite car? Tejas, what is your favorite car? Let us make BMW. Okay, what first law wanted to say? If we want to give 100 joule of energy, it should work 100 joule of energy. Is it practically OD? Okay. Entropy of the universe is increasing due to spontaneity? Of course, sir. So, Bentley, okay, Rolls-Royce. Okay, let us come to the academical discussion here. Nice sharing with you views. So, you want to use Audi or you want to use Bentley, you should be standing in a professionally good position, then you will be doing that, right? So, for that we all rise together and you can do the best. Okay. Now, what first law says, if you give 100% of 100 joule of energy, it should do 100 joule of work. Some energy is lost, 100% efficient engine isn't physically possible. Yes, but if you consider it is whenever you observe 100 joule work is not done, 100% engine is not doing so. Sir, you say some kind of friction, assume it is no friction. Okay, thermal loss is there, assume it is thermally insulated. तभी ऐसा हो रहा है. It's not possible क्योंकि ये system जो है ना, this is the system. Okay, okay, this time Bentley. Okay, if 100 joule of energy is given, if 100 joule of energy is given, maybe it is doing 95 joule of work. There is not possibility of doing the 100% work. Then where this 5 joule of energy is going out? Yes, the system is using 5 joule of energy. System is using 5 joule of energy for what? To increase the entropy. So we are going to study the concept of entropy. Hope you understand. So the main course of the second law of thermodynamics is that. So this is the heat and this is the work, and you can't do work unless something is compensated. This is what is called entropy change, that is compensated. You want to buy something, you have to buy by paying the total amount, but the cost of the object is very less, little less. I just want to say tax you have to pay. So by default tax should be going on. Okay, unless you pay tax you can't purchase it. You go to a hotel and you just enjoy a good meal. Okay, so the bill come along with the tax. Total amount you expended is actually what you have, but also you have to pay the tax. Are you getting or not? That tax kind of the analogy is given for the entropy. What do you say? Kushi Gupta. Right. Now let's talk about the second law of thermodynamics. So concept of entropy. So the concept of entropy comes if the particles represent the gas molecule at normal temperature inside a closed container, which illustrates the configuration of the first. It is randomly arranged and it is organized. It is organized and it is disorganized. It is called ordered, and this is what you call it as a disorder. So this is a disorder. this is a disorder in case of tossed bricks, in case of gas. So, how much organized, how much disorganized is there? How much organized, how much disorganized is there? This is what you call disorder. This is what you call it as a disorder. That disorder measure करने के लिए हमारा thermodynamics में एक state function चाहिए, that is called entropy. So just I was trying to say that entropy, when a hot iron bar comes in contact with cold, this is a hot iron bar comes in contact with the cold surroundings. So what happens? The energy will always flow from कहाँ से कहाँ तक जाना है? हॉटर बॉडी से कोल्डर बॉडी तक जाना के कोशिश करते हैं. सो दैट दिस इज द हीट फ्लो. सो दिस इज स्पॉन्टेनियस. So heat always flows from hotter body to colder body, and the energy flow from the more vigorous molecules to less vigorous molecules, you can say. And we can also say energy tends to disperse. It will never happen. Net energy is transferred from low temperature to high temperature, low temperature to high temperature. It never happen, but it spontaneously it happen. Hotter body to colder body, higher temperature to lower temperature, without any external force. So this process, what do you call it, as a spontaneous process. Are you can do from the colder body to hotter body. Heat can be transferred, but you have to do a lot of external work, what Tejas is saying, right? Is that you want to say? Yes. So I just want to say there are two observations. First observation, matter has a natural tendency to be in disordered or randomized. This is a natural tendency, yeah. This is a natural tendency where matter wanted to be disorganized. The particles inside the matter wanted to be disorganized. And energy has a tendency to become disordered or dispersed. Whenever energy is concentrated at one point, so it is highly unstable, system is always unstable. But energy is dispersed throughout the body, as dispersed as possible, and it is going to be more stable. And these are the two parameters that makes it introduction of the entropy. And let us talk about entropy is a measure of randomness or a disorder. It is a state function represented by S. It is state function represented by S. S stands for entropy. Absolute entropy you can't calculate, rather change in entropy can be calculated. Basically I think whatever decrease in the internal energy of anything, that's where spontaneity tends to hold up. Yes, of course. Okay, and as I want to say, we can safely say that it is it's a spontaneous process. There is a tendency to increase entropy. Yes, of course, safely, not all the way, not all the way. Okay, I want to say entropy is one parameter. Hence the statement of the second law, I just want to say entropy of an isolated system or the universe tends to increase. Abhishek and Tejas wanted to say the same. And also you can say the spontaneous process, the entropy of the universe increases. What's that? What do you mean by the universe over here? What do you mean by the universe over here? System plus surroundings. No? Yeah, you said recently. Yes, you are ahead with me, huh, Tejas. Yes, system plus surroundings. Okay? And also the absolute value of entropy is not significant, as a change in entropy during the process is significant, and the change in entropy of a process, you can say delta S is equal to sum of the S products, sum of the S reactants. In thermodynamics, any absolute value of the entropy or enthalpy of Gibbs free energy you cannot measure, rather the change can be measured, right? And it is said that delta S is equal to heat reversible upon the temperature, okay. Now as temperature increases, Tejas, it is the ratio of the heat absorbed by the system isothermally and reversibly to the temperature at which it is absorbed. That is the ratio. And this is what exactly wanted as a mathematical form of the second law of thermodynamics. In other ways, we can say entropy of the system plus entropy of the surroundings should be greater than 0. So entropy should be increased. Universe entropy should be increased, right? And my question is simple. My question is very simple here. We just discussed, as you are more enthusiastic in the class, I just want to ask a question. We just discussed delta S is equal to Q reversible upon T. Now, you just keep this side here. I just want to ask you, if we are calculating delta S, okay, should it be delta T instead of T? Not an issue. T, that is T, Abhishek. Okay, now let's talk about a body at 25 degrees centigrade and a body at 250 degrees centigrade. So it is an entropy here and it is an entropy here. It is an entropy here, entropy here, S2. So I just want to say S2 and S1, whose entropy is more? Whose entropy is more? Whose entropy is more? Make it fast. Depends on the body. Okay, same body. The body of this is same. Body of this is same body. The same body. Thermodynamics you learn like that only. 250. Okay, I just want to say S2 is greater than S1. Okay, that's fine. That's fine. That's fine. The one with higher temperature, Abhishek said correct, and Tejas also said correct. What about Anu? Now, can you contradict this? Temperature is and in the denominator. Entropy is and temperature are inversely related. The one with higher temperature you said. My question is, this is rock solid discussion, hai na? So delta S is increases if temperature is decreases. According to this, how it is possible? But your answer is correct. Your answer is correct. कभी सोचा है ये फॉर्मूला का हिसाब से एंट्रोपी इंक्रीज करना है या डिक्रीज करना है? सुपर है. हाँ ना. If it is an isothermal process, adiabatic process, तभी तो है. Okay, if that is the case, you have to say thermodynamics entropy is nothing but it is number of microscopic energy states at that level. Okay, microscopic energy states. Okay, so that we can have kind of discussions, but mathematically that is true, and experiment visually this is true, but you don't correlate this. To correlate this, you have to talk about the microscopic energy states concept by taking the Boltzmann constant into the act, actually which is not required for the NEET examination. यही तो ये अब फिलहाल जो आंसर दिया ये करेक्ट है, वही तो ये करेक्ट है, ठीक है मैडम, डोंट हैव टू वरी अबाउट दैट. बट थर्मोडायनेमिक्स सीखने का ऐसा तरीका होता है, ये तरीका सीखने का कोशिश करो, ठीक है. एंड ऑल्सो विल डिस्कस सो मेनी थिंग्स इन टुडेज क्लास. Yeah, entropy, right? And talking about the entropy here, we discussed the second law of thermodynamics. So, entropy change of the universe is equal to entropy of the system plus entropy of the surroundings should be greater than 0 for all non-spontaneous process. And for example, heat flow from a system of high temperature to surrounding to the low temperature, that's a spontaneous process. And you can say for calculation of entropy, change in entropy is equal to change in heat at the reversible process upon a temperature, not a delta T, you know. So, integral ds is equal to integral dq reversible upon temperature, and the change in entropy delta S is equal to integral dq reversible upon temperature, and it is the mathematical form of the, this is the mathematical form of the second law of thermodynamics. Delta S is a state function and the Joule Kelvin inverse is the unit. Generally, enthalpy and internal energy, Gibbs free energies, those values are at the range of kilojoules in the order. But entropy, its values are going to be Joule Kelvin inverse. You understand? Clear? Now, talking about calculation of entropy in various processes, let's talk about case 1. For a reversible heating and cooling of a solids or liquids. Don't apply this for the gaseous system. So, ds is equal to dq reversible and ds is equal to n integral molar heat capacity of dt by t. And this derivations which is actually not required. If the Cm is independent of the temperature, delta S is equal to number of moles Cm molar heat capacity ln T2 by T1, just mathematical treatment and a mathematical version of the various processes. This is one way, and also I want to summarize everything at the end. And to case 2, in case of a real gas, previous one it was for the solids or the liquids, but it is for the gases. For the case of real gas undergoing isobaric reversible process. In this isobaric reversible process, ds is equal to dq reversible, heat reversible upon temperature at constant pressure. That is the reason why it is mentioned that isobaric is equal to ncp molar heat capacity at constant pressure m and dt by t. And also you can say that at temperature T1 it's Cp1, at temperature T2 it's Cp2, or otherwise you can say delta S is equal to Ncp m ln T2 upon T1. And wherever I am making a box, you write these formulas and maintain a cheat sheet so that you are going to prepare these formulas just before you go for the NEET examination, my dear children. Yes, Teja, if increases, if S increases, T increases. Abhishek Acharya, very good. Now every process I maintain these slides for you. In case of real gas undergoing isochoric reversible. Isochoric reversible means dV is equal to 0. Previous one is isobaric is equal to dP is equal to 0. है ना? Yes. If delta S increases, T increases. Now you see isochoric process dV is equal to 0. So ds is equal to dq reversible at a constant volume upon T. So n CVm dt by dt. So heat capacity, molar heat capacity at a constant volume, that is CV. And we discussed in the previous classes Cp and the CV relations and all. And also delta S is equal to n CVm ln T2 by T1. Okay, so this is the formula for a real gas undergoing isochoric reversible, yes, reversible process. Okay, one is copying by my name. Oh, somebody is copied your name. Your Tejas, na? That one is Teja. Okay, Tej. Good name. Right? No, nobody copied your name. Okay, you are unique. Tejas always unique. Abhishek Acharya, basically increasing the pressure following the basic gas law. Yes, of course, increasing the pressure and the volume decreases. Tejas, yes, that's good. 1 minute please. Now case 1, case 2, case 3, this is the third case, and we go ahead with the other case like case 4. If the phase transformation occurs like solid become liquid, liquid become solid, kind of things. I am in study app, thermodynamics, Infinity Learn. Okay, Infinity Learn, you can just follow my YouTube classes, or otherwise you can just join any class of various batches are there with Infinity Learn, and I will be teaching so many batches with various groups. So that's Kushi. And I mean that isochoric process, temperature increases leads to the pressure increase according to the gas law. Isochoric process here, the volume is constant, Charles Gay-Lussac law, according to that you are true. And what I found, yeah, Abhishek Acharya, what you said is correct. And the previous message I found it is a basic gas law, increase in pressure you said. Increase in the pressure, first law we learn about the Boyle's law, I applied that. So you have to say isochoric process dV is equal to 0. For that, agar temperature बढ़ जाए तो pressure भी बढ़ जाता है. Right. Okay, now you can see so at a boiling point or at a melting point or sublimation point, the process is considered as a reversible process. The process is considered as reversible process. So whenever a liquid is converted into gas, that is what you call enthalpy of evaporation is equal to heat transferred in the reversible process, because at that particular process the system is at equilibrium with the two phases and it is said to be a reversible. हिंदी में जानकारी कर सकते हैं कुशी गुप्ता, अगर कुछ डाउट है ना तो पूछ लो, मैं एक्सप्लेन करना चाहता हूँ आपको. ओके, राइट. सो for enthalpy of evaporation है Q reversible by temperature, that is Q reversible process जो है enthalpy of evaporation का बराबर होते हैं delta H vap by temperature that is considered to be boiling point, है ना. And I just want to say this is for delta S vaporization is equal to enthalpy of vaporization and temperature, boiling point temperature ka. So you have to take that boiling point temperature only. Okay. English language, huh? Okay, comfortable here. And enthalpy of fusion, उसमें क्या होता है, solid becomes liquid, evaporation में liquid becomes gas. Okay, enthalpy of fusion, entropy of fusion is equal to enthalpy of fusion upon melting point temperature, fusion temperature. This is a fusion temperature. Okay? And also case 1, for an ideal gas undergoing any process, okay, so that is reversibly taken as directly you can see delta S is equal dq reversible upon temperature, right? Carefully you see, for the change you have to say from du minus dw by t, that is the heat change, that is the heat transferred, okay, and that is equal to integral from the n number of moles, n should come here, not a matter, Cv upon T minus P dV upon temperature. Okay, solid becomes liquid at its melting point, so we give the melting point temperature. Yes, correct, Tejas, right? And from here delta S is equal to n Cv m ln T2 upon T1, that Cv ln T2 upon T1 plus ln n r ln V2 upon V1, यहाँ से ये वाला, यहाँ से ये वाला, and on doing so at constant temperature, PV is a constant, okay, so P2 V2 upon P1 V1 and V2 by V1 directly is taken. From there you can directly take this T2 upon T1 here, so delta S is equal to NCV ln T2 upon T1 plus nr ln P1 upon P2. So you can directly take this formula before your examination, right? Wherever I am writing the formulas, these formulas you take into the consideration and you try to do the best, and you don't have to do complicated numericals based on this, rather you can do these things and can be better. And talking about this expression can be applied, so if you open a book you will be having hundreds of formulas, and in my class Suresh Sir is giving to you when to apply, when not to apply it. This expression can be applied to any process, even to an irreversible process, as entropy is a state function and doesn't matter what is the path. It's a state function. It depends only on the state, initial state and the final state. You know? And also expression for certain processes, and this particular slide is very important for the NEET examination. Those students who are attending for the NEET examination, follow this. You know? Right? And for isothermal process, delta S is equal to n r ln V2 upon V1, n r ln logarithm V2 upon V1, we can say, for your clarity, delta S is equal to n r ln V2 upon V1, like that. And for isosteric process, you have to go in the first attempt. Yes, of course. N CVln T2 upon T1, molar heat capacity at constant volume, and I have given the Cp and the Cv relations also. And for isobaric process, delta S is equal to N Cp ln T2 upon T1, it can be derived directly. And also for adiabatic process delta S is equal to 0 because heat change is 0. जब तक heat change 0 है तब तक entropy भी 0 होना चाहिए. Yes, exactly. Abhishek took a long expression from the previous slide and modulated it according to different conditions. I agree with that. So in my second attempt, I secured 554 marks in my first attempt. Oh, and you have seen the first slide of the day. Abhishek Acharya and Tejas. Himadhyati got 310 marks. She got 650 marks. अच्छा बात है ना, अच्छा बात है. आप भी ऐसे बना सकते हैं. अरे अगर हम YouTube में क्लास अटेंड करते हैं तो आलतू फालतू चलेगा ना? नहीं, बिल्कुल नहीं. अगर आप YouTube में क्लास अटेंड कर सकते हैं, आप नीट का सीट भी निकाल सकते हैं. अरे टॉप पर भी बना सकते हैं. आप सही सुना. यस, बट sincerely you have to work, sincerely you have to follow the lectures messages, है ना. पढ़ाई करने के बाद पढ़ाई लेते हैं. हाँ, पक्का. अभिषेक आचार्य एंड तेजस, आज आपके साथ मैं क्लास में बहुत एंजॉय कर रहा हूँ. ऐसे इंटरेक्शन होना चाहिए, अदरवाइज रेडियो सेशंस नहीं होगा ना. ये लाइव इंटरैक्टिव सेशंस बेटा. Perfect, perfect. Write the testimonial. Write the testimonial, Tejas. And you better you write score examination बेटा. Okay, आपका score examination का वजह से आपको पूरा what do you say 100% scholarship भी मिलेगा. पढ़ाई और अच्छा होगा, पढ़ाई और अच्छा होगा, है ना. Everybody in the class, please attend the score examination that is given in the description box. Okay, Infinity Learn is offering a score examination. It is pinned on the chat box. Okay, 611 last attempt. Let's hope for it goes good. 650 plus 680 मिलेगा. यकीन है, भरोसा भी दे रहा हूं मेरा तरफ से, आपको मिलेगा 680 700 के आसपास में. आप ठीक है मैडम, चलो. एंड दिस इज वेरी इंपॉर्टेंट, दिस इज वेरी इंपॉर्टेंट. थैंक यू. एंड लेट्स सम फैक्ट्स अबाउट एंट्रोपी ऑफ एन आइडियल गैस. एंट्रोपी ऑफ एन आइडियल गैस. इट इज फॉर आइडियल गैस. First of all, entropy of a system remains constant in a reversible adiabatic process. It is also known as a acentropic process. Acentropic process, the terminology बहुत important for the same reason. Why not 720? Can't we do? हाँ, we can do. If you have faith on you, we are ready to make you to get 720 out of 720. Infinity Learn by Sri Chaitanya में 2024 NEET में 720 out of 720 हमारा तरफ से निकला हो, है ना. Yes. So scams on NEET 2024. So my confidence levels decreases. Okay, if that is the case, और जो बदमाशी करने दो. जो बदमाशी करने वाले हैं ना, उसके हिसाब से करने दो. ओके, हमारा ये जो वर्क डन होता है ना, हमारा जो कॉन्फिडेंस होता है ना, ओके, कुछ फर्क नहीं पड़ता. दैट इज द एटीट्यूड यू हैव टू डेवलप इट, है ना, है ना बेटा. Let it be many things, but we have to try our own best and you will be the best. ठीक है. Next, in a reversible adiabatic process, the entropy of both system and surroundings remain the same, and there is no overall change in the entropy as well. Acha hai na? There is no entropy change. And also delta S system is equal to delta S surroundings is equal to delta S total is equal to 0. That is for an ideal gas, entropy of the system in constant reversible process. Got it? And also entropy of an ideal gas will always increase in isothermal expressions only, expansions only. Whenever expansion happens, no, gas molecules move here and there. Kinetic energy भी बढ़ जाएगा, है ना? And also one more point I want to give you about the entropy in an irreversible isothermal expansion. The entropy of the surroundings will always decreases to the balance the increase in system's entropy to make the overall entropy constant. That is an isothermal expansion process, क्योंकि temperature constant का है ना बेटा? हाँ, और एक चीज़ है, for in a free expansion the entropy of the system always increases and the surroundings remains constant. But free expansion in both isothermal and adiabatic is, and it is irreversible. And also points to remember, very important. अरे entropy चीज़ का कैसे apply करना है, this is a very important. Total 10 points or 10 or 12 points are there. I am going to explain the 10 or 12 points so that you can do anything based on the entropy. Mind it, if you given a question from the second law of thermodynamics, you will be asked at least a logic oriented question or simply a what you say theory oriented question. Numericals कम आता है क्योंकि ये logical objective oriented questions में इसी चीज़ का आता है. So points to remember, if the temperature of a system increases, entropy definitely increases. Don't contradict that delta S is equal to Q reversible by temperature. You don't contradict with this because we need to explain these microscopic states of the matter. Okay. So macroscopic, you know it, microscopic, you don't need it. Okay. So if the temperature of a system decreases, entropy decreases. Yes, of course, entropy decreases. You know, one more important point, for a fixed volume of the system, entropy increases if the number of molecules increases in a system and vice versa. As number of molecules increases, what happens? As number of molecules increases, randomness increases, chaos increases, disorderness increases. Okay? And also, for a system with a fixed number of molecules, entropy increases as volume increases and vice versa. As volume is increased, molecules are more randomly move here and there. Okay? So, as a number of particles, number of molecules, state of a body, temperature, internal energy, these type of questions regarding entropy, I have confounded. Okay, Abhishek Acharya. Okay, that's nice to share your views. Okay, nice. Right, let's go. Entropy of system increases with change in the state of a system. Okay, solid is changed to liquid, liquid is changed to gas. So entropy of the system of the solid is less, entropy of the system is the liquid is more. So here entropy is increasing in this order. Entropy is increasing in this order. Understand? And also entropy of more complex molecules is larger than the simpler molecules, as in the more complex molecules there are more ways arranging atoms in 3D, more randomness. I just want to say entropy of propane is greater than entropy of ethane at given temperature. Okay, so I mean to say 1 liter of propane you take, 1 liter of ethane you take. Okay? So I just want to say entropy of more complex molecule is larger than that of simpler molecules. ठीक है? That's very important. And entropy of compounds with similar molecular mass increases with increase in their size. So entropy, size, atomic molecular volume. So n pentane is more than isopentane is more than neopentane, है ना? Like that. So as molecular volume increases, entropy increases. Very important. Simple molecule देख के पता चलेगा where we are more branching. Okay, जहाँ पर branching ज़्यादा है वहाँ पर entropy कम है. अभिषेक आचार्य, ठीक है मैडम? Fine. Okay. Now और एक चीज है, entropy of ionic solids becomes larger as the attraction among the ions becomes weaker. सोडियम फ्लोराइड का एंट्रोपी ज़्यादा है, मैग्नीशियम ऑक्साइड का एंट्रोपी कम है. मैग्नीशियम ऑक्साइड +2 ऑक्सीडेशन स्टेट का है, +2 एंड -2 का. हियर +1 एंड -1 का. ठीक है? सो as more, yes, Abhishek got this, sir. And harder the substance will have smaller entropy than the softer substances. Yeah, क्या बात है. अच्छा, you are getting an extraordinary content in today's class. So entropy of diamond is less, then entropy of graphite is less, then entropy of iron, entropy of aluminum, entropy of sodium, like that. Okay, so let's talk about here graphite and diamond. Entropy of graphite is more than entropy of diamond, है ना? अभिषेक आचार्य, खुशी गुप्ता and तेजस, समझ में आ रहा है क्या? बट and all spontaneous process are irreversible process or vice versa. Okay, so spontaneous process are reversible, non-spontaneous process are irreversible. And I just want to say for an isolated system, entropy is greater than 0. That process, what you call it as a process, spontaneous process. Okay, if entropy is less than 0, is said to be process is non-spontaneous. If entropy is 0, the process is reversible or at equilibrium. So this is the generalized version on safe side, I just want to say. And also just I want to say conclusion, या हमारा conclusion कैसे दे सकते हैं? In an isolated system, an increase in entropy represent the direction of natural change. Generally we deal with closed systems. We don't talk about the open system. Open system has a n number of deviations. And this closed system and not with an isolated cause system interact with the surroundings. When our system is interacting with surroundings, we are going to see the system and the surroundings will have so many exchanges. I want to say entropy of system plus surrounding is equal to universe. So entropy of the universe upon entropy of the universe or the total is equal to entropy of the system plus entropy of the surroundings. So I just want to say entropy of the universe is equal to entropy of the system plus entropy of the surroundings. If it is a greater than 0, that process is irreversible process. That is what is called as second law of thermodynamics. Yes, naturally उसका entropy बदलते जाते हैं. Abhishek, that's good. Okay, Kushal Gupta, Kushi Gupta, and what about no name is given, Tejas. Okay, if delta S total is greater than 0, process is spontaneous, just we discussed. Less than 0, non-spontaneous. delta S total is the reversible or at equilibrium, है ना. So for delta S surroundings is equal to Q surroundings in the reversible upon time is equal to minus Q system upon temperature. So if the activities of temperature is surroundings is not mentioned, then we have to take the final temperature of the system as temperature of the surroundings. That's very important. Okay, so certain points we need to admit how it has to be taken from this way to that way. Okay, so we have isothermal reversible process, delta S is equal to minus delta S of the system from the surroundings, and also for isothermal irreversible process, delta S system is equal to minus P external change in the volume upon temperature, considering it is a reversible process. So many processes it is given for the free expansion, it is isothermal free expansion, it will also be adiabatic too, it is going to be Abhishek Acharya, delta S is supposed to be 0, for it is an adiabatic process, delta S total is equal to delta S is equal to N or ln V2 upon V1. For also adiabatic process, you can see, for adiabatic process we are coming to the close of the system, close of the second law of thermodynamics. Yes, it is system delta S total is equal to delta S system plus delta S surroundings, delta S is 0, delta S T is 0, so it is supposed to be 0, है ना, clear button. And also for adiabatic irreversible process, delta S is equal to 0, this is C, okay, delta S is equal to NCVM ln T2 upon T1 plus N or ln V2 upon V1. So this derivation also we have seen, है ना. For free expansion, delta S is going to be 0, so delta S is equal to N or ln V2 upon V1. Like that, the total second law of thermodynamics and entropy changes we have seen. And what is the physical significance of entropy? At the end, conclusion note, dear children. Okay, Abhishek Acharya, I want you to be more interactive in the class. So, physical significance of entropy. It represents the extent of randomness. Entropy of the gas is much more greater than liquid is greater than entropy of the solid. है ना? And on increase in the temperature, randomness will increase. So this is about the physical significance of entropy. Abhishek, how do you like class today? Kushi, Tejas? And in the next class, today we discussed about first law of thermodynamics, need of second law of thermodynamics, and entropy, and mathematical form of the second law of thermodynamics, and various conditions, isobaric, isochoric, adiabatic, and free expansions, isothermal expansions, various concepts we have seen. And the next class we are going to see connected to this Gibbs free energy. सिर्फ आपके लिए एक क्लास लेना चाहता हूँ. Okay, best. Thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. Thank you all. Please like and share and subscribe the sessions. Thank you. Next class कल recording होगा, recording sessions कल आएगा, and the day after tomorrow I think we'll do it. Okay, you just join in the Telegram channel, you will understand when is our next class. ठीक है, bye bye, God bless you. Signing off, Suresh, Faculty of Chemistry. Thank you very much. Bye.